Today we are learning the law of sines. This is a formula that you will have to memorize. But before I just give you the formula, we are going to derive the law of sines formula. So notice we have triangle ABC, and we are first going to look at this right triangle here on the left side. And I want to calculate the sine of angle A. And we talked about sine yesterday, and sine is opposite over hypotenuse. So for this right triangle, what is the opposite side from angle A? H. And the hypotenuse is B. Now we're going to solve that for H. So if H is being divided by B, the opposite would be multiplied by B. So that would give us B times the sine of A is equal to H. Now, pause button. Leave that equation alone for a minute. Now we're going to look at the right triangle on the right side. So now I'm looking at this right triangle in red. Now I want to find the sine for angle B. So what is the side opposite of angle B? H. And what is the hypotenuse? A. Just like we did on the last equation, we're going to solve for H. So if H is being divided by A, the opposite would be multiply both sides by A. So that will give us A times the sine of B is equal to H. Now what do you notice? Both of those equal H. So now we're going to use the transitive property. So if H equals B times the sine of A, and H also equals A times the sine of B, then those are equal. So set them equal. So this would be B times the sine of A is equal to A times the sine of B, and that's the transitive property. Now the next thing I want to do is I want to divide both sides by AB. And that's legal because if I divide the left side by AB, I need to do the same operation to the right side. So divide both sides by AB. And on the left side, B in the numerator, B in the denominator, that cancels. So that leaves us with the sine of A over side A is equal to. Now on the right side of the equal sign, A in the numerator, A in the denominator, they cancel. And that leaves us with the sine of B over side B. And that gets us to the law of sine. Now this just has two sides of the triangle, but triangles have three sides. So we can just extend this little observation and say that the sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is equal to the sine of angle C divided by side C. And I'm going to box this in, and I'm going to put a note beside it that right here inside this box, this is called the law of sine. You need to memorize it. You probably already have it memorized by now, right? Sine of A over side A is equal to sine of B over side B, which is equal to sine of C over side C. So all three of those proportions or ratios are equal. Now when it comes to utilizing it and actually using the formula, we'll just use two sides. So we'll use like A and B together or A and C. We won't do all three at one time. So we'll have a proportion, so only two sides. Now the same is true about the inverse. And if you invert these fractions, side A over sine of A is also equal to side B divided by sine of B, which is also equal to side C divided by the sine of angle C. Now what's in the box is what's most common if you look in textbooks. So if you just looked up the law of sine from your textbook, what I have boxed in, that's what those textbooks will use. But right there below it, it's also true. Okay, so let's start. Now, the first case is if you are given angle, side. So A AS, remember from your geometry days, that stands for angle, angle, side. So if you are given angle, angle, side in a triangle, then you could either have no solution or you could have one solution. Now for one solution, that means we'll have a value for angle A, we'll have a value for angle B, we'll have a value for angle C, a value for side A, a value for side B, and a value for side C. So we are going to be solving these triangles just like what we did yesterday when we were solving the right triangles. You need to solve for all three sides and all three angles. Now, is this a right triangle? No, this is called an oblique triangle. It does not have a right angle. So since it does not have a right angle, you cannot use SOHCAHTOA. That is only for right triangles. And you cannot use Pythagorean theorem because that is only for right triangles. So if you have an oblique triangle, you will have to solve the triangle using the law of sine, which is that formula we just derived. Now, for my answers, I'm going to go ahead and fill in the information that was given to us. So on that triangle, they gave us angle C is 102 degrees. Angle B is 29 degrees. And side B is 27.4. Now, what is not given, we now have to solve. What would be the easiest and fastest to find first? Angle A, because I know all three angles should add up to how many degrees? 180 degrees. So I need to do 180 degrees. And if you add these two together, what is 29 degrees plus 102 degrees? 131 degrees. And what's 180 degrees minus 131 degrees? 49 degrees. So there's one of our answers. Angle A is 49 degrees. Now, we are going to use the law of sine to find side A as well as side C. When you're using the law of sine, you need one angle and side pair. So we already have an angle and side pair with the B value. So we're going to do sine of angle B divided by side B is equal to, let's solve for side A first. So if I want to solve for A first, I would have to set this equal to the sine of A. So sine of angle A divided by side A. So we're only going to use two sides at a time. So we have the pair of B given. Now we're going to solve for side A. Now fill in what they gave us. Now I'm not going to write this formula down every single time, but this first one I'm going to make sure you see what is going where and what we're doing. So for this first one, this would be sine, and angle B is how many degrees? 29 degrees. Side B is 27.4. That ratio is equal to the sine of angle A, and angle A is how many degrees? 49 degrees. And side A, that's what we're solving for. Now, I have a proportion. So to solve a proportion, I need to cross multiply. So this would be A times the sine of 29 degrees is equal to the other cross product is 27.4 times the sine of 49 degrees. Solving for A. Right now, A is being multiplied by the sine of 29 degrees. So the opposite of multiplying by the sine of 29 degrees, divide both sides by the sine of 29 degrees. Now we're not using calculators until the very end. So we're at the very last step, so now we can use the calculator. Now make sure you're in degree mode. And it's a good rule of thumb to put the numerator in parentheses and then divide by sine of 29 degrees. And for sides, we're going to round to the nearest 10. So let me know what you get for A to the nearest 10. 42.7. 42.7. Do we agree? So up here at the top, side A is 42.7. Now we need to solve for side C. So I have my original pair of sine of angle B divided by side B. Now we need to solve for angle, not angle. Now we need to solve for side C. So this needs to be sine of angle C divided by side C. Now again, this first problem, I'm going to actually write out that formula, but on the next ones I won't be writing this part out. Now, fill in what they gave us. So this would be sine, and what do I put for angle B? 29 degrees. And for side B, 27.4. Now for sine of C, that would be sine of what degree? 102 degrees. And we are solving for side C. Now we need to solve this proportion. So cross multiply, so this would be C times the sine of 29 degrees is equal to 27.4 times the sine of 102 degrees. Divide both sides by the sine of 29 degrees. What did you get? 55.3. 55.3. Do we agree? Remember, put the numerator in parentheses. Do we agree with 55.3? Okay. The side of C is 55.3. So there is our one solution. We have all three angles and all three sides. Okay, next problem. Notice this one is also angle, angle, side. So I can have either no solution or one solution. So let me go ahead and write out my blank. So I need angle A, angle B, angle C. I need side A, side B, and side C. Then fill in the given information. So angle A is 129 degrees. Angle B is 19 degrees. Side B is 10.5. Now we need to find side A, angle C, and side C. Now, that third angle would be the fastest one to find. We know these angles add up to 180 degrees. And what's 129 plus 19? 148. So what's 180 degrees minus 148 degrees? 32 degrees. So there's one answer. 32 degrees for angle C. Now to find side A, I have to use the law of sines. I cannot use SOHCAHTOA. I cannot use Pythagorean theorem because this is not a right triangle. So I have to use law of sines here. So this time, I have my angle and side pair. So I have to do sine of B over B. And let's go ahead and solve for side A. So we need to do A and B. So starting with B, this would be sine of 19 degrees divided by, what is the side for B? 10.5. Now we're doing A. So this would be sine of 129 degrees over A. So sine of B over side B is equal to sine of A over side A. Cross multiply. So this would be A times the sine of 19 degrees equals 10.5 times the sine of 129 degrees. Divide both sides by the sine of 19 degrees. And side lengths go round to the nearest 10. Make sure the numerator is in parentheses. 25.1, do we agree?
Yes.
So side A is 25.1. Can I do Pythagorean theorem to find that third side? No, why not? This is not a right triangle, so we have to do law of sines again. Okay, so now we need to do sine of B and sine of C. So this would be sine of 19 degrees over 10.5. And now we need to do sine of C over side C. So this would be sine, and C is 32 degrees over side C. Cross multiply, that gives us C times the sine of 19 degrees is equal to 10.5 times the sine of 32 degrees. Divide both sides by the sine of 19 degrees. And what is C to the nearest 10? 17.1. 17.1. Sounds like we all agree on that. So that one has one solution. Next one. Let's see. This is angle. Let's see what's happening here. So looking at my angles, A is 150 degrees. Angle B is 36 degrees. What does angle C have to be for that to add up to 180 degrees? What do you mean it doesn't work out? Yeah, if you add these two up, they add up to 186 degrees. Is that possible?
Nope.
No. So this one is no solution. So the three angles cannot add up to more than 180 degrees. Yes?
What do they mean by like more than like one solution? Or like you keep saying that there's one solution. So we
If it's angle, side, it's either one solution or no solution. But once we get to the side angle, you could have no solution, one solution, or two solutions. And we'll see what the two solutions look like. But for this case, if you have angle, side, you would not have to worry about two solutions. So next one. Now, this is side angle. So notice we are given a side, and angle. So if you're given side angle, you could have no solution, you could have one solution, or you could have two solutions. So what would two solutions look like? Let me show you. So we'll have angle A, angle B, angle C. We'll have side A, side B, side C. That makes us one solution. But, yeah, wrong. If you have side angle, you could have two solutions. So this would be the second solution over here, angle A, angle B, angle C. Side A, side B, side C.
no.
Now, fill in what they gave us. So, they gave us the angle A is 42 degrees. So both cases, angle A is 42 degrees. They gave us two side lengths. Side A is 22. So both cases, side A is 22. Side B is 12. So both cases, side B is 12. Now, we need to use the law of sines to find some of this missing information. So we'll start with case 1. If you want to label these, here's case number 1. Here's case number 2. Now, looking at what I have, which two sides will I have to use? A and B, A and C, B and C, A and C. Notice I have 3 out of the 4. Do I have any info on side C?
No.
No, so I have to do A and C. So we'll have to do sine of A, so that would be sine of 42 degrees, divided by side A, which is 22, is equal to sine of angle B, divided by side B, is 12. Now, Cross multiply. So this would be 22 times the sine of angle B is equal to 12 times the sine of 42 degrees. We want to get the B by itself, so divide both sides by 22. So that gives us the sine of angle B is equal to 12 times the sine of 42 degrees over 22. Now notice, this is the arc sine value. This is the answer for sine. So in the calculator, you'll have to do sine inverse. So in the calculator, you need to do second and then sine of that fraction. And make sure the numerator is in parentheses. So do second sine of that fraction. And for our angle, we'll round to the nearest degree, unless they state otherwise. So round to the nearest whole degree. 21 degrees? Do we agree? Okay, so let me fill in my cases. So that's the answer for case 1. So over here, B is 21 degrees. Now this is where students get confused for some reason. To find angle B for case 2, you subtract from 180 degrees. If I take 180 degrees and subtract the case 1 degree, which was 21 degrees, what is 180 degrees minus 21 degrees? 159 degrees? Would that be possible to have a triangle with a 42-degree angle, a 159-degree angle, plus a third angle? No. So case 2 is not possible. So you do have to check to see if it's feasible. So we don't have to worry about case 2 anymore. We're done with it because the angles add up to more than 180 degrees. So to get angle B for case 2, just subtract B from 180 degrees in case 1. Now, we need to finish this out and find angle C. And angle C, well, if I add these together, those add up to 63. So what's 180 degrees minus 63 degrees? 117 degrees? Okay, so now we're ready to finish that out. So I'm going to use what was given to us. We were given angle A and side A. So let's do sine of angle A is 42 degrees, divided by side A, which is 22, is equal to sine of 117 degrees over what? C. That's angle C, so it needs to be over side C. Now cross multiply, so this would be C times the sine of 42 degrees is equal to 22 times the sine of 117 degrees. Divide both sides by sine of 42 degrees. Rounding sides to the nearest 10, what would C be to the nearest 10? 29.3. 29.3? Do we agree? 29.3. There is our answer. We only had case 1. Why was case 2 not even feasible? The angles added up to more than 180 degrees. So this one only has one solution. Next example. Notice they gave us angle side side. If they give you angle side side, how many cases could you have? 2. Go ahead and write out your cases. And then fill in what they gave you. So the given information, angle A is 83 degrees. Side A is 15. Side B is 25. So it's going to be the same given information for both cases. Now, what should we solve for next? Angle B. We have 3 out of the 4 for A and B. So we need to do sine of A over A equals sine of B over B. So starting with sine of A, this would be sine of 83 degrees over side A is 15. That's equal to the sine of B divided by side B, which is 25. Cross multiplying, we get 15 times the sine of angle B is equal to 25 times the sine of 83 degrees. Divide both sides by 15. So that gives us sine of B equals 25 times the sine of 83 degrees over 15. Now, when you put this in the calculator, this is the arc sine value. This is the answer for sine. So you'll have to do arc sine, which would be second sine of this fraction, and make sure the numerator has parentheses. And we're going to round to the nearest whole degree. What are you doing? What are you whispering over there? You just said, did you get a what? Did you get an error?
Yeah.
Yeah. Okay. So, did you get an error? Yeah, you all did. So, if you get an error message, no solution. No solution. Let me tell you why. If you actually put this in the calculator, the sine of B, type in just this fraction. I want to know what is an approximation for that fraction.
$1.6.
1.6 approximately.
1.6.
So that's why we're getting the error message. Now you don't know this, and you shouldn't know this, but we will be graphing some trigonometric functions later this semester. And this function right here is what the graph of the sine function looks like. And the graph of the sine function, the highest it could even go up to would be +1. The lowest it can drop down to would be -1. So that's what the problem is. Our sine value is 1.6, so it's up here. Is that on the graph? No. So if you want to double check, make sure if this answer is bigger than 1, it's going to be no solution. So if you get that error message, no solution, move on. You don't have to do anything else. Next one. Angle side side. How many cases would this have? 2. Write out your 2 cases. Once you have your 2 cases written out, fill in the given information for both cases. Angle A is 20 degrees. Side A is 12. Side B is 31. What should we solve for first? Angle B. So we need to do sine of A over A. So this would be sine of 20 degrees over 12 is equal to sine of B over side B. Oh, and instead of side B, what should I put for side B? 31. Cross multiply, this would be 12 times the sine of B is equal to 31 times the sine of 20 degrees. Divide both sides by 12. And this is an arc sine value, so what do you have to remember when you're typing this into the calculator? Make sure you do sine inverse, so do second sine. And we'll round to the nearest whole degree. What did you get? 62 degrees? Do we agree? Yes, we agree? So for case 1, angle B is 62 degrees. Over here for case 2, how do I figure out how many degrees B would be? Subtract from 180 degrees. So we need to do 180 degrees minus 62 degrees. And how many degrees would that be? 118 degrees. Would it be possible for a triangle to have a 20-degree angle, a 118-degree angle, plus an additional angle? Yes. Good. So this one does have the two cases. Okay, so we have to finish this. Well, let's find angle C. So back to case 1. 20 degrees plus 62 degrees is 82 degrees. And what is 180 degrees minus 82 degrees? 98 degrees. And for case 2, 118 plus 120 degrees adds up to 138 degrees. And what's 180 degrees minus 138 degrees? 42 degrees. Okay, now we need 2 more answers. So now, let's see. We were given angle A and side A. So let's do sine of angle A is 20 degrees over 12 is equal to, now we're doing case 1 first. So if we're solving for side C, this needs to be sine of angle C divided by C. Cross multiply, that would be C times the sine of 20 degrees equals 12 times the sine of 98 degrees, and divide both sides by the sine of 20 degrees. And we're going to round to the nearest 10. We agree with 34.7? So 34.7. Now for case 2. Notice for case 1, we did sine of 20 degrees over 12, right? Case 2, does it have that same pair? Yeah. But if I'm doing sine of A over A and sine of C over C, how would that change for case 2, looking at what we did for case 1?
Sine 42 is 90.
Right, instead of 98 degrees, change it to 42 degrees. So in the calculator, we need to do 12 times the sine, instead of 98 degrees, change it to 42 degrees, and divide by the sine of 20 degrees. 23.5. Do we agree? Okay. 23.5. Now, what if you only put case 1? How much credit do you think you would lose? Half credit, so make sure if it's side-side angle, you have both cases. Next one. Now it says draw each triangle. How is this one different? We're not given the triangle, so we need to draw our own diagram. So just quickly sketch you a triangle. It doesn't have to be perfect by any means. Label it ABC. And mark what they gave you. That angle A is 32 degrees. Side A is 4.5. And angle B is 82 degrees. Now, the only reason why you really need to draw this triangle is so that you can see, do you have side-side angle, or do you have angle, side. What's the case here? Angle, side. So what's the most number of cases I can have? Luckily, it's just one. Fill in what you know. We know angle A is 32 degrees. We know angle B is 82 degrees. And we know side A is 4.5. Now we can find angle C pretty quickly. If I add 32 degrees and 82 degrees, what do those add up to? 114? And what's 180 degrees minus 114 degrees? 66 degrees. So angle C is 66 degrees. Now, do we want to solve for B or C first? B. So we'll have to do sine of A over A, sine of B over B. So let's sum together. So sine of 32 degrees over 4.5 is equal to sine of 82 degrees over side B. Cross multiply, that gives us B times the sine of 32 degrees is equal to 4.5 times the sine of 82 degrees. Divide both sides by the sine of 32 degrees. And for sides, we'll round them to the nearest tenth.
8.4.
8.4, we agree?
Mm-hmm.
So side B is 8.4. Now for side C, we'll do A and C paired together, so sine of 32 degrees divided by 4.5 is equal to sine of 66 degrees over side C. Now why do I not want to use 82 degrees and 8.4 as a pair? Yes, it's rounded. So make sure you use what's given if you do have it given. So don't use a rounded answer unless there's no way around it. So this would be C times the sine of 32 degrees equals 4.5 times the sine of 66 degrees. Divide both sides by the sine of 32 degrees. We agree with 7.8?
Yes.
Yes? It's 7.8. So one case, we're going to start with that one case. Okay, we're going to do a little bit of skipping. I want you to do number 9. Let's draw it. We're skipping number 8. Go to number 9. Draw your triangle A, B, C. Label what they gave us. Side C is 115. Angle C is 43 degrees. And side B is 138. They gave us side angle. How many cases could we have? 2. I want you to do this one. We'll check your answers here in a few minutes. Which angle would we have to find first? Do we have any information on A? No, so I have to find angle B first. So I have to do sine of B over B is equal to sine of C over C. So starting with the pair that's given, this would be sine of 43 degrees over side C is 115 equals sine of angle B divided by 138. Cross multiplying, that gives me 115 times the sine of angle B is equal to 138 times the sine of 43 degrees. Divide both sides by 115. And what do I have to remember when I'm putting this into the calculator? Second sine. This is the arc sine value. So to the nearest whole degree, what's the angle for, what is the degree measure for angle B to the nearest whole degree? 55? We agree? So for case 1, it's 55 degrees. How do I find the answer for case 2? Subtract from 180. So what is 180 degrees minus 55 degrees? 125 degrees. Now I can find the other missing side, not the missing side, but the other missing angle. So for case 1, 55 plus 43 would be 98 degrees. And what is 180 degrees minus 98 degrees? 82 degrees. And for case 2, 125 degrees plus 43 degrees is 168 degrees. And what is 180 degrees minus 168 degrees? 12 degrees. Now solving for side A, use the pair that they gave you. So we have sine of C and side C. Don't use anything that's been rounded if you can avoid that. So sine of 43 degrees over 115 degrees, or 115. Now for case 1, this would be sine of what? 82 degrees for angle A over side A. Cross multiplying, that would be 8 times the sine of 43 degrees is equal to 115 times the sine of 82 degrees. Divide both sides by the sine of 43 degrees. And what is side A for case 1 to the nearest 10? 167? So 167.0. Now for case 2, we still have sine of 43 degrees over 115, but instead of 82 degrees, what do we have for angle A? 12 degrees. Okay, so we need to change 82 degrees to 12 degrees. So for the other side A, that would be 115 times the sine of 12 degrees divided by sine of 43 degrees. And what is that? 35.1. And we are finished. 35.1. Now, if you only had one case, you would miss half your credit, so make sure if there's two cases, you have both cases.